In this video, we will look at the idea of constant growth factors. A function relationship has a constant growth factor if whenever one quantity changes by some fixed amount, the other quantity becomes a constant number of times as large. So for example, whenever x changes by 1, y becomes 1.3 times as large. In this case, we say this relationship has a constant growth factor. We would say that the 1 unit growth factor of y is 1.3. And this 1.3 comes from the fact that if x changes by 1 unit, y becomes 1.3 times as large. This is kind of a hard idea, so let's look at a few examples that leverage this idea. Consider the following example. A magic vine has an initial length of 5 feet and doubles in length each day. So anytime one day passes, the length of the vine doubles. We know that the length of this vine doubles each day. And doubling is the same thing as the length of the vine becomes 2 times as large. So doubling is the same as becoming 2 times as large. So anytime one day passes, the length of the vine becomes 2 times as large. And therefore, we have a constant growth factor in this situation. We would say that the 1 day growth factor, so the 1 day growth factor in this scenario is 2. So each time 1 day passes, the length of the vine becomes 2 times as large. Let's consider another example. We have a table of values for a relationship between x and y, and we want to know if there is a constant growth factor. So first we'll look at this table, and we see that on the left-hand column we have values of x, and then on the right we have values of y. So between the first two rows, we see that x increases by 1. And y, in this case, it varies from 4 to 6, and therefore y becomes 6 divided by 4, which equals 1.5 times as large. So in this case, when x increases by 1, y becomes 1.5 times as large. So I'll just put times 6/4, which equals 1.5. Then from x equals 1 to 2, x again increases by 1 unit, and y simultaneously varies from 6 to 9. And to vary from 6 to 9, y becomes 1.5 times as large, and that just comes from 9 divided by 6. So in this case, each time x is increasing by 1 unit, y is becoming 1.5 times as large. Now from x equals 2 to x equals 5, that's an increase of x of 3 units. So x changes by 3 units, and then y is going to become this 30.375 divided by 9 times as large. So we can compute that value, and that's 3.375. So when x increases by 3 in this case, y becomes 3.375 times as large. If we do the computation from x equals 5 to x equals 8, that's another change in x of 3, and y again becomes 3.375 times as large. So in this case, we do have a constant growth factor. We could say a couple things. The 1 unit growth factor, so 1 unit, I'll abbreviate growth factor as GF. The 1 unit growth factor is 1.5 because whenever x changes by 1 unit, y becomes 1.5 times as large. And similarly, we could say that the 3 unit growth factor is equal to 3.375 because whenever x changes by 3 units, y becomes 3.375 times as large. Let's look at one last example that's in a graphical context. So we have a relationship between x and y. So we have a function relationship here. What I have here is I can vary the value of x, and then represented by this red vector, I have a change in x of 1 represented. And then each one of these blue segments represents a value of y, the corresponding value of y. So this first shorter blue segment represents the value of y at this initial value of x, and then the second blue segment represents the value of y 1 unit later in x. So as I vary this initial value of x, the initial and final value of y are going to vary. So as I do this, it looks like this second y value is about 1.5 times as large as the initial value, but we could actually be a little more precise with that. So if we compute the ratio, 6.57 divided by 4.38, which I'll put right here, 6.57 divided by 4.38 is equal to 1.5. And therefore, that final value of y is 1.5 times as large as the initial value of y. So as x changes by 1 unit, the final value of y is 1.5 times as large as this initial value of y. Now, if I vary this initial value of x, both of these y values are going to vary, but the ratio of the final y value to that initial y value is going to be constantly 1.5. So if you watch this ratio, the ratio of the final y value to the initial y value is constantly 1.5, meaning that that y value at the end of the interval is always 1.5 times as large as the value of y at the beginning of the interval. So in this case, we say that we have a 1 unit growth factor of 1.5.